An inscribed angle. This is where we start getting into some serious stuff. An inscribed angle. Here's how you know if an angle is inscribed. The vertex is on the circle. As you can see here, here's an angle ABC. Well, where is the vertex? It's on the circle. And the rule is that there's a 2-to-1 ratio between these. The arc that's contained by it, this arc, will always be twice as big as that angle measure. So since this is 36 degrees, this has to be twice as big. That's going to be 72 degrees right here. You can see that this angle is inscribed in a circle because its vertex is on the circle right here. We have the arc measure, so the angle is always half as much. There's a 2-to-1 ratio. The arc is twice the angle, so if that's 62, this has to be 31 degrees right here. And then here, this guy, it's on the circle again, right? So the arc that's contained by it, this entire red arc is contained by that green angle right there. If that's 113 degrees, this has to be twice as much and get 226 degrees right here. So inscribed angles. And they get kind of complicated. Let me give you a better problem before we get to one of these here. Alright, so check it out. I got arc AD measuring 100 degrees right here. This red arc measures 100 degrees. Well, do you see that it is totally contained in this green angle right here? That's an inscribed angle because its vertex is on the circle. So if this is 100 degrees, that has to measure 50 degrees. But do you also see that that red angle is totally containing that red arc also? So let's change the color to blue. If I get a highlighter, that's what I'm looking for. See, this blue angle right here is totally contained by that 100-degree angle also, so it measures 50 degrees. And both of these angles were inscribed in the same arc right here. They contain the exact same arc, so they have to measure the same, right? They're half 100, half 100. So if inscribed angles are inscribed in the same arc, then they measure the same amount. Well, that's what we're doing here with all these crazy expressions. They say, find the measure of angle U. Well, here's angle U right here. Let's change colors. Here's angle U right here. Its vertex is on the circle. Well, what I would love is to know, I don't have either this or the arc that's contained by it. I would love to know this arc measure right here. Well, this arc is actually, that blue arc is contained by this as well. This 30 degrees. So since this is 30 degrees, this guy right here has to be twice as much, but isn't both the green angle and the red angle both containing that blue arc? So this has got to be 30 degrees. And we're putting this information in the picture also. That's going to help you do many, 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 many things. So put information in the picture. Measure of angle U is 30 degrees. Cool. Now I'm going to erase my highlighter parts of this so we can kind of see what's going on. But I'm still keeping that information of 30 degrees and 60 degrees. They say find the measure of angle T. Well, angle T is inscribed because the vertex is on the circle. So right there. And it's inscribed in this arc UV right here. So I don't know angle T. It's got an expression of 3x plus 4. And it's inscribed in this blue arc, but you can see that this blue arc also contains this green. I'm just following that puppy out till I get on the circle. This green one, angle W, is also on the circle. It's got an expression of 2x plus 9. So since these two angles, the red angle and the green angle, are inscribed in the same blue arc, they have to be equal to each other. So I can say 2x plus 9 has got to equal 3x plus 4. And solve for x. So subtract x from both sides, subtract 2x from both sides, subtract 4, and 5 equals x. But now they want the measure of angle T, so I got to substitute that back in. I got to put 5 in for x. So 3 times 5 is 15, plus 4 more is 19 degrees. I could check to see if I did it right by making sure this is still 19 degrees. 2 times 5 is 10, plus 9 more is 19 degrees. That's good in the neighborhood. So measure of angle T equals 19 degrees right here. It's a tough thing, so let's try another one right here. It says find the measure of angle A. Well, angle A, follow it out till I get to a place on the circle. That's the idea. Highlighters are a good thing here, right? So grab a highlighter if you need one. Here's angle A. It's inscribed in this green arc right here. Well, if I could find another angle inscribed in that green arc, that'd be good. So do you see how B is one of the endpoints of that green arc? This guy's touching angle B. If I could follow it to a place on the circle, boom, got it. And C was the endpoint of that green arc. Follow it to a place on the circle. Aha, this red angle is also inscribed in that green arc. So since the blue angle and the red angle are inscribed in the same green arc, they have to be the same amount. So this is the blue angle, this is the red angle, 6y minus 2. It's got to equal 5y plus 8. And now I'll subtract 5y. Add 2, and y equals 10. Now we could substitute that in. That'd be 60 minus 2, which is 58 degrees. I better get 58 here, so that'd be 50 plus 8, which is 58 degrees. That's a good check that I solved right. Measure of angle A is 58 degrees. Notice I put that in the picture and answered the question. Measure of angle C, let me erase. That's the beauty of my awesome InterWrite board, is I can erase my highlighter stuff. You can't, so you just got to use a lot of colors. Measure of angle C, they want this right here. So here's C, and I follow it out until I get to points on the circle. So it's inscribed in this arc right here, and red. There's the end points of that arc right there. If I could follow that dude out to where I get to on the circle again, you can see that this is 6x minus 3, and that guy right there is 7x minus 11. Those are the two angles that are inscribed in the same arc. So 6x minus 3 equals 7x minus 11. Add 11 to both sides, and x equals 8. And that'd be 48 minus 3, which is 45 degrees. I better get 45 degrees here. 7 times 8 is 56. Take away 11, which is 45 degrees. So nice. That's not the easy thing to do, so if you need some help with that, please come see me, and I will definitely help you with that one-on-one. Here, check this out. They don't really give us the same kind of tricks to use, but the circle's best friend shows up, and that is this guy, the diameter. That splits us up into two semicircles, meaning this arc right here is 180 degrees. Well, isn't this angle, angle Y, inscribed in a semicircle? That is the whole 180 degree arc right here. So that means that this angle right here is 90 degrees, half as much. And we get an awesome little shape right here and here. We get a triangle, and one of the angles is 90 degrees. It's a right triangle, so the other two angles have to add up to be 90, because all three angles add up to be 180. So we know this is 90. There's 90 left over. So x plus 12 plus this other x right here add up to equal 90 degrees, right? Because that's how much is left over. Well, these are like terms on the same side, so I'll combine them and get 2x plus 12 equals 90, and subtract 12, 2x equals 78, and then x would equal 39. So I put that in the picture. This is 39 degrees. This is 39 plus 12, which is 51 degrees. So they say find the measure of angle W. That's 51 degrees. So angles that are inscribed in a semicircle obviously measure 90 degrees. And we got that because of the diameter. The diameter cuts a circle into two equal pieces. Once again, here's a diameter. This angle right here is inscribed in this semicircle, which measures 180 degrees, so that's got to be 90 degrees, meaning these two angles in this red triangle that I have right here have to add up to be 90, so 2x plus 4x minus 6 equals 90, 6x minus 6 equals 90, 6x equals 96, and x equals 16, baby. And then that would mean, when we put that in, that this is 32 degrees, and this is 58 degrees. Find the measure of angle T, 58 degrees. So that's section 10.4. and 10-3, both of them. Inscribed angles, vertex is on the circle. Central angles, vertex is the center. Central means same, inscribed means ratio of 2 to 1. So let me know if you have any questions, and have a good one.